Okay. A week ago is not that far back. It's not that far back. But in the last week, I've been posting a lot of the content we've been studying, including videos on trigonometry, where we discuss the theory, the formative principles. I just want to see if I've got anything about, I've got reduction. We've got reduction rather. We've got solving without a calculator. We've got, okay, grade 10 is basics. Okay, it looks like a lot of the trig we have, there's no sine rule or cos rule. Yeah. Okay. Maybe we might do an hour of that. Maybe we can do an hour of that. That's fine. Trigonometry.
I hate trigonometry, and I'm sure it hates me right back.
That's not the correct attitude to have towards math. It's probably why you didn't do well in the exam. You're not supposed to hate your studies. You're supposed to say, I'm not sure I absorb the content yet, but I will in future. Then you will understand it in future, you know?
When you do it without loving it, you
You'll
do it
struggle
because it's
with
your
it.
responsibility.
Well, we all have to do things we don't like so we can enjoy the things we want to enjoy.
Ah, you just pulled a discipline pool. I knew you would say that.
It's just what it is, man.
I
It's just what it
expected you to
is.
say that. I pushed you in that direction.
It's just what it is. It's just what it is. Okay. All right, fine. Sine and cos rule. And then, Tiamo, what did you have in mind to discuss today? So we can do 1 hour on either.
Euclidean.
Euclidean geometry.
He's not friendly.
Euclidean geometry. Okay. So, first things first, to get a good foundation of Euclidean geometry. Let's see. Do we have video content? Oh, we've only discussed similar triangles. Okay, then that's fine. We have a good basis for today's discussion, eh? Magdalene, should I share Jamboard? Magdalene?
You should get this checked out.
I probably should.
No.
I don't have to share Jamboard.
Because it sounds serious.
Yeah, it sounds like my computer is sick, ne? Okay, so you, Tiamo, will navigate the Jamboard for us so that we can switch between two things, ne?
Aye, Captain.
Between slides, sorry. On this computer, I would like to open up. Let me open up.
Friends.
Just in case what? Just in case your network escapes.
Magdalene. That's a very interesting name.
Magdalene. Mary Magdalene from the Bible. You know her?
But I never knew that her name was Magdalene.
There's Mary, Jesus' mom, and then there's Mary Magdalene, who's always featuring in Jesus' stories.
Oh.
But as to in what capacity, some literature is...
So that's where the word Magdalene came from.
The name Magdalene, yes. The name. Also, one of my late aunts was Magdalene. So, yeah. All right. So, we've got... Okay. So, let's start with sine rule. Usually, we get it from grade 11, I believe.
Sine rule.
Sine rule and cos rule, yes. We started from grade 11. I'm just gonna go to the Mind the Gap learning guide because it gives a nice background for that. Trigonometry. So trigonometry, sine and cos rules, ne? So we'll start with sine and cos rules, and alright, page 222, that would be 255, let's see. We're close. We are close. So Tiama, I'm just gonna use the Mind the Gap learning guide because it's relevant to your grade 12, but the sine and cos rules that we do learn from the same book or learning guide are the same ones that we learn in grade 11 rather, because we don't do sine and cos rule in grade 10. Ne? So primarily sine, cos, and tan. Remember trigonometry? Trigonometry is triangle measure, ne? It's the measurement of triangles. So triangle measure, ne? So these ratios typically apply to 90-degree angled triangles. So right angled triangles. Yes? That being said, it's easy to determine if we have alpha there and beta there, what sine alpha is, what cos alpha is, and what tan alpha is, as well as the sine of beta, the cos of beta, which they equal like this, as well as the tan of beta. Yeah? But now what happens when we don't happen to have a 90-degree triangle? So what if there is no 90-degree angle? So that's where sine rule, cos rule, and there's a third one, area rule. So I'll just erase these rules here and I'll write area rule. Ne? That's when we use then sine, cos, and area rule become relevant, ne? Relevant. But how? How does that happen? Okay, so we'll start our theory from right-angled triangles, just so we revise, ne? So with right-angled triangles, if we have a right-angled triangle that looks like this, and the one angle is 37 degrees, the one angle is 90 degrees, so this would be 90 degrees minus 37 degrees, yeah? And we know that this side is 16 centimeters long. Up there is point A, at the right angle is point C, and at 37 degrees is point B. So given this triangle ABC, we must find AB and BC. Ne? So Magdalene, on your calculator, take it out quick. We start with AB. How will we find AB? AB is our hypotenuse, yes? It's this side here. So how do we find it? If we know 37-degree angle and we've got this side is opposite the 37-degree angle. And the trig ratio, as with the other videos for trigonometry that can be referenced and notes, the trig ratio that has an opposite side and a hypotenuse is sine. So we will say the sine of 37 degrees must equal AC over AB. And we know AC is 16. But we do not know AB. However, we can find the sine of 37 degrees. So what we do, we take multiplicative inverses, and then AB will equal 16 centimeters over the sine of 37 degrees. Now we punch all of that into our calculators and correct to 2 decimal places. That should be 37 sine invert times 16. It gives us, I get 26 comma to 1 decimal place, comma 6 centimeter. What do you get?
Same thing.
You get same thing. Magdalene?
They have the same results.
Magdalene? Also. She was entertained with the thumbs up.
It kills me every time.
I'm glad you enjoy it.
You'd be like, if you don't understand, use the emoji.
So for us here, we see it, but unfortunately for our YouTube viewers, you can't see what's going on our video call. But yeah.
Understand.
But yeah, so because Magdalene's joining us at a different location remotely, and Siamo's in person, so that's great. Right, now we do the second one where we must find BC. The BC is this side here. We can do it 2 ways. We can either subtract 37 degrees from 90 degrees and use the same trig ratio for sine, or we can go right ahead and say, since this side is adjacent the 37-degree angle or next to it, we can use the cosine of 37 degrees and say that it equals BC over AB. Now we've got AB, which is 26,6, but we are looking for BC. We are calculating BC. So we can multiply the 26,6 by cos of
37.
Oh, cos of 37. And what's the answer? I get 21.5. Is that correct?
Something's wrong with my calculator. Wait, let me restart it.
I get 21.5.
Mine gave me 10 to the exponent of power 10.
There's something you did not do right there. And it looks kind of right. I mean, if this side...
them.
I just multiplied the answer I got previously with the cosine of 37. So if I am to identify the hypotenuse with the color blue, then that will be 26.6 centimeters. And if I am to identify BC, the adjacent, with a green color, that would be 21.5 centimeters. Looks like it could be correct because, I mean, a 37 degree would be a shallow angle, meaning the length BC should be longer, and it should be considerably longer than AC. So this should be considerably longer than AC. So it looks like it could be correct. Tiama, did you try it again and get a similar answer?
Yeah.
21 point something. That's great. I got 21.5 for the simple reason that I did not round off my answer on the calculator when I multiplied by cos of 37. So that's why I get 21.5. But 21 roughly should be the correct answer. Also, we can still apply Pythagoras theorem.
X squared plus y squared equals to r squared.
So you can try that out on your own. And if you are watching the video, you can pause, do the calculation, and then check. But yeah, so I want to run through this quickly. We can do another right angled triangle whereby, oh, you're still writing.
I mean,
Okay, you can switch to the next slide. We have another right angled triangle. And Magdalene, these are exam type questions that you can also find in your matric final, your grade 12 final. So our triangle has at the right angle angle P for Mr. P. It's also got angle R and angle Q, which has got theta there. And the side PR is 13 meters and PQ is 12.3 meters. Meters. That's not N, that's M. So we must find the angle at Q, which is angle theta, right? So we can shift this triangle around, or you can rotate your book, it doesn't matter. But if we shift the triangle around and resketch it as follows, that would be P, that would be Q, and that would be R over there. Yes, so that would be, mine is not to scale, so the one side is probably gonna look shorter than it should, but let me just redraw it. So that this is 12.3, that is 13, this is theta, and we don't know what RQ's length is. So even if we don't know what RQ's length is, would you like to guess which trig ratio we can use? Bless you.
thank you.
If we are to guess a trig ratio to use, we can use tan of theta, because in this case, we've got the opposite. Or rather, let me use a yellow color because I tend to use that one for the opposite side.
So you can use tan. Okay.
Yeah.
Tan in terms of X, Y, and R. How do I arrange it here?
How do you arrange it?
Yes.
That is a very good question. Let me just finish with my color coding and then I'll answer that. In terms of X, Y, and R.
Yes.
All right. We are going to do just that shortly. I just want to do this. And I also want to do this. Right. Now, one of the definitions that we discussed in some of the other videos, and we'll probably discuss again should we need to revise trig, be it for an exam type question or the like. But this scenario, we can think about it in the context of a unit circle. If we have a unit, or not even a unit circle, let's use these dimensions. Let's say from 0 to to P, let's say the origin is at point Q, and at P, we've got 12.3 meter length. And then this is on the X y plane. Are you starting to see now where x and r and y are falling in? Yeah, now you see it. So if we are going to go in this direction, that is without a doubt the x direction, right? So from the y-axis to the right, we are going in the x direction. That means from the x-axis above, we're going in the y direction. So for this triangle, we will need to go from 0 and count 12.3 meters that way. And then at that point, at 90 degrees to the x-axis, parallel to the y-axis, we will go up 13 meters. So now, Tiamo, does it start to make sense?
Yeah.
How the x and y would feature in this.
Yeah.
And then if we go from the origin, kind of like how a vector works in physics really, then we connect those, the head to tail method, then we get our hypotenuse. So now we can use tan. And how we will use tan? So tan theta would be y over x, and it will also be opposite over adjacent. And in this case, theta is unknown, but we know that y is 13 meters and x is 12.3 meters. So the units divide each other out to give 1, because tan is a ratio that does not have a dimension or units. Then we've got the answer of 13 divided by 12.3, and that is equals to 1,0569 what, but that equals tan theta. Now to calculate theta, we need to work out the arctan of 1,0569 what, and that will give us an answer. Now it is okay for tan to give you a number that can go between 0 and it can even go higher than 1. And that is because on the graph of the function of tan, sine and cos oscillate between 1 and -1. But tan does go higher than that. And that would look something like this. So your sine graph between 0 and 360 degrees would look like that. Let me rather use a blue color for sine. Oh no, a yellow color for sine since it's a y. So sine would look like that. Cos, which is adjacent, we'll use green, would look something like this. And sine and cos are also co-functions of each other, by the way. So because they are co-functions of each other, what it means is there's a 90-degree difference between either of them. So where cos starts, sine starts 90 degrees later on the function. And then tan would go something like this. And that would be an asymptote, but again from -infinity all the way.
Infinity.
Yes, and it'll repeat like that. So it's okay for the function of tan to be above 1 or below -1, but that's not the point now. The point is when we work out the arctan, I get 46.6 degrees. So this would be 46.6 degrees. Let's just quickly check. Magdalene, is that the same answer you get? 100%. That was a very speedy response. You are clearly eager to go to area and cos rule. So now we start with area rule. Ne? So now area rule, after we've done the basics, we start off with the area of a right angled triangle, ne? So area of a right angled triangle is its area of the triangle half times the base times the perpendicular height. Ne? Because this would be the height, this would be the base, and then the area would be half times base times height. By the way, from a geometric perspective, that is because a right angled triangle is half of a rectangle. Half. Yes, a right angled triangle is half of a rectangle. So it makes sense that the area of a right angled triangle would be half times the base times the height. Right? So, yeah. And we can also think about it like this for this kind of triangle, where that is a right angled triangle. Then the perpendicular height would be like that. And this would be the base. Now, let's start with the proof. Ne? Let's start with the proof. So we're going to do the proof for when the triangle has got an acute angle and for when the triangle has got an obtuse angle. And we're going to derive the area rule formula for either triangle. But we will find that it gives us the same thing. And because of that proof, we will take that formula as it is. Ne? And then we'll make some notes as to what to look out for when the angle is like this or the triangle is like that. So I'll just make a split screen like that. So for an acute angle, we'll start with that and then we'll do an obtuse angle. So for an acute angle, let's say we've got our triangle and it's got an acute angle. Ne? So our height is going to look something like that. And our triangle is ACB. And our base is from A to C. Now, where that height intersects AC, we'll call that point D. So now we've got two triangles. We've got triangles ABD and BCD. Yeah? ABD and BCD. Those are the two triangles that we've got. Right. So now the area of triangle ABC will equal half times the base times the height, and that's a formula we are familiar with. But now our base, or rather, if we look at the angle A, ne? If we look at the angle A, the sine of A equals BD, which is the perpendicular height, divide by the hypotenuse is AB. Okay, so I'm just gonna give this side AB the letter C to indicate that it's opposite side angle C, and I'll give BC the letter A to indicate that it's opposite angle A, and AC we'll call it B. because it's opposite angle B. That should make our proof a lot more simpler. So we can then say BD is H, which is the perpendicular height, and AB is C. So that's our first manipulation. Then H, in terms of sine A and the side AB, would be C sine of angle A. Ne? If we substitute this into our Formula 1, not the race car sport, not the race car sport, then we will have the area of triangle ABC will equal half times B times C sine of angle A. Ne? And what this tells us is that in this triangle, if we are going to look for the area of triangle ABC, and we've only got the size of angle A, we've got the length of B, and the length of C, then we can work out the area. And we don't even need to know that one of the right angles is a right angled triangle, which we could use if we knew the perpendicular height. But because we don't, and we had to substitute it as a function of the sine of one of the angles, then we can already conclude that, then from this proof, we can conclude that the area of triangle ABC is half times the side B times the side C times the sine of angle A. And what this means is we have to look for a side, an angle next to the side, and a side that is sandwiching that angle there. So in other words, if we are going to look for the area of triangle ABC, but we've got angle B, side A and side C, we can work out the area, and that's because we know this side, that side, and this angle. So other ways, other proofs can apply the same way, but it also means that the area of triangle ABC equals a half times side A times side C times the sine of B, and the area of triangle ABC equals a half times B times C times the sine of, oh, that's the first one. Yeah, that's the first one. So I've got BC, I've got AC, so I should have, I've got BC, I've got AC
times C.
So it should be A and B times A times the sine of angle C, because it would be A and B and sine C. And we can also do the same for an obtuse angled triangle, where if that is angle A, that's C, and that's B, this here is the perpendicular height, which is at 90-degree angles. If that is angle A and that's side A, that's side B, and that's side C, then this angle should be 180 degrees minus angle A. Then the area of triangle ABC, hey, this thing is loud, eh?
It's giving me a headache.
Sounds like we're in a factory. It's a half times the base times the perpendicular height. But now, in the triangle outside of our triangle, if that point is D, Sine of 180 degrees minus angle A will equal that perpendicular height divide by the hypotenuse. Yes. So height divided by hypotenuse, and if we use reduction formulae, there's a lot of notes on this. This becomes sine of angle A. Remember, in our cast diagram, second quadrant is 180 degrees minus theta, if we have theta there.
It's supposed to be 90.
No, it's 180 degrees.
Isn't it like 360, 90, 180, 270?
It's 0 and 360 here. 0 and 360 at this, 90 degrees there, 180 degrees there, and 270 degrees there. So, yes. So, hear me out. So when we've got a protractor and we sit it on this, we sit it on here, when we count from 0 degrees, we will count 180 there. Correct? So if we are to subtract that angle of theta, let's say it's 10 degrees. If we subtract 10 degrees from 180 degrees, in which quadrant will we fall? We'll get 170 degrees and we will fall in this quadrant. Do you get it?
I get you.
So 180 degrees minus theta, when we reduce it, it remains theta for sine, and the sine is positive. So that's why it reduces to sine of angle A. That equals h over c. Therefore, h equals c sine of angle A. Now we're going to substitute that into our original triangle formula for the area. ABC will equal a half times B times C times sine of angle A. Likewise, these two also apply there in the interest of time. Ne? Alright, so let's quickly do an example. But before we do an example, Magdalene, quick thumbs up. Yes, that's what I like to see. Alright, cool. So now we do a quick example. If we are given a triangle, obtuse angled triangle, interesting, and it's K, N, and M, so that will be small k, small m, and small n. This side is 4.8 units long, or let's say centimeters. This side is 3.5 centimeters long. We don't know how long K is, but we must find the area of triangle KMN. Find area of triangle KMN, and we will use the area rule. So this would be half times, remember we've got, the angle that's given is K, which is 112 degrees. Yes, we're given that. So that would be the side KN, which is M, and the side MK, not the political party, which is N, and the sine of the angle K. So this would be a half times 3.5 times 4.8 times sine of 112 degrees.
You said that M, 1/2 times M. Why is M 3.5 all of a sudden?
M is 3.5, N is 4.8.
But then why are they so...
Are you okay?
I'm not okay.
Would you like to have some more water?
Yes.
Refresh, by all means, refresh. So, when we calculate
I have a dream.
Martin Luther King, that's almost like these symbols in the triangle. So we've got 0.5 times 4.8 times 3.5, that's 8.4, times the sine of 112, and that gives us 7.788 square centimeters. This one should be clear enough. I want to move to sine rule. So, okay, I'm not going to do the proofs. We'll do the proofs in another class. Ne? So sine rule. Otherwise, we're going to eat into the next hour. Okay, but let's see if we can do this in 15 minutes. Sine rule. So sine rule, long and short of it, if you have a triangle and it's A, B, C, so that's C, that's B, that's A. Oh, thank you. And here we also have cos rule. Ne? So cos rule, and we also have a similar triangle, and not similarity in the sense of geometry, but a triangle that's like that. Yeah.
Proportionality.
Okay. So what the rule is for sine rule, and sine rule is my favorite because it's just so simple to use and apply. Right?
Mm-hmm.
Or maybe we can prove sine rule quick. So, but what it says is that the sine of angle A divided by side A equals the sine of angle B divided by side B and equals the sine of angle C divided by sine C. Right? And if we have an acute or obtuse triangle, then if we have a half BC sine of angle A, then it should equal half AC. Okay, that's an alert. How much time we got left? 15 minutes. In a few minutes time, we'll extend the call. So that's 15 minutes time. So in just before quarter past. Yeah. So half AC.
Just before quarter past, my mom started cooking now.
So you're gonna have dinner when you have studied. That's
Yeah.
good. Half, not BC, AB sine C. So if we divide each of these by a half ABC, if we divide each of these by a half ABC, then for this instance, the B and the C will divide each other out, the halves will divide each other out, and we're just left with sine A divided by A equals sine B divided by B equals sine C divided by C. And that right there is our proof. Right? So Magdalene, for your self-study, you can go through this calculation, this step here, so that maybe you grasp the concept. But for now, you can just observe. And of course, this video should be up online by either tonight or tomorrow night or tomorrow morning. So whenever you get the chance, you can watch the video anytime just to refresh. Ne? And then this applies to obtuse and acute angled triangles. Ne? And if you would like, I will share the link for grade 9 where I discuss, or rather where the grade 9 class and I, we discuss the different types of triangles, and an acute as well as an obtuse angle triangle are some of those types of triangles. All right. Similarly, here C over the sine of angle C equals B over the sine of angle B equals A over the sine of angle A. You can use these two interchangeably, but pick a format. Ne? But it's important to pick a format. Ne? And that format, you cannot use this one and equate it with that one. It won't work. But you must use, if you use where you start with the side divided by the trig ratio of the opposite angle, then keep the consistency. Keep consistency. But if you use this one where you start with the trig ratio of an angle divided by the side opposite the angle, keep the consistency. Ne? Otherwise, you will not get full marks. Ne? You will not get full marks. And Tiamo, for exam purposes, you will get examined on this. So it's an examinable proof. So if you know how to prove the area rule, then you can prove the sine rule. Because the area rule, once you've proven it, you'll get to this stage, which is where you'll get to the stage where you get the area of the triangle. And now to get to sine rule, you just divide by half times the product of all of the sides. And that should give you sine of the angle divided by the side that remains, that is opposite the angle. And you can equate that to the other things, to the other sides. Yeah? So, which is this step here. So once you've proven, so after proving area rule, then you divide by a half ABC. Napile chai. Yeah, so you can practice proving this area rule, and then after practicing proving the area rule, you just divide by a half times A times B times C, and you should get that. But in any case, even if when you're applying now this to a problem, you can use this format or that format, but keep the consistency. We don't go this format and that format. That is wrong. Now, cos rule is a bit longer to prove. Or rather, before we go to cos rule, because I'm going to have to come back here, we'll just use an example here. So we'll do an example so that in the next slide, we prove cos rule. Right, so we've got a triangle. It's XYZ.
Pokemon.
XYZ, yes. So there's angle Y, angle X, angle Z, side X, side Y, side Z. Angle Y is 96 degrees. Angle X is 43 degrees. We don't know angle Z.
We do. The small Z though.
We know the length of the side of Z. So that is equals to 7,3 meters. Do we know side Y? We don't know side Y. Do we know side X?
No.
We don't know side X. So we must solve this triangle. So solve simply means find angle Z, side X, and side Y. And we must correct to 3 decimal places. Ne?
Yes.
Right. So angle Z is straightforward. It should equal 180 degrees minus 43 degrees minus 96 degrees. And that is because the angles of a triangle are 180 degrees. Ne? Right. Then that gives us Z equals 41 degrees. Okay. Now to find Y, we can say Y divided by sine of angle Y equals Z divided by sine of angle Z. So we will say Y equals Y over sine Y equals Z over sine Z. Because we've got the length of side Z, we just substitute. So this means that we've got 7,3 over the sine of angle Y. We have got 96 degrees there. Z, we've got, oh no, I'm making a big blunder there. Big blunder. Y is the one we are looking for. It is not 7,3 meters. So that's the blunder I made, substituting Z for Y. Ne? And then Z is 7,3 meters. And we are now going to substitute also the 41 degrees that we calculated for angle Z. Now we take multiplicative inverses. So this will mean 7,3 meters times the sine of 96 degrees divided by the sine of 41 degrees. So now remember, sine does not have units. So we'll have meters as units for Y because it is a length. Then this means we've got we've got sine of 41 times sine of 96 times 7,3. My answer is 11,066.
Mine is 11,16.
11,16. Magdalene, how much do you get? Same answer or different?
No.
How much do you get?
110,660.
What?
110,660.
Darling, double check your calculator for me. Can you please check it?
Oh, I thought it was 73, 7,3. So.
Oh, okay. That's fine. Then you will do it again with the correct measurement of 7,3. Ne? It should give you 11,6. Then I'll just make a space here. I really don't want to make next slide. So we will have x over sine of angle x should equal z divided by sine of angle z, which means we have x
Why?
over sine 43 is equals to 7,3 divided by sine of 41. Then we take additive inverses, or rather multiplicative inverses. Therefore, x will be 7,3 times sine 43 degrees divided by sine 41 degrees, and that is equals to it's 41 sine invert times 43 sine equals times 7.3 equals, and that gives us, what's your answer, Magdalene?
7,589.
100%. Well done for getting that. Siamo, you also got the same, yeah?
But it's 2 8. Hers, I heard it's 9.
Oh, yes, because when you round at 3 decimal places, the last decimal that where you cut the decimal fraction at, you round it up if the number that comes after it is 5 or more. And you round it down.
If it's 5 or more.
Yes. And then you round it down if it, or you keep it the same rather. You don't round it down. You keep it the same if it's 4 or less. So because the number that comes after the 8 is a 6, it's 5 or more. So then the number that you stop at, which is 8, becomes a 9.
She rounded it off.
Yes, so that is the rounding off exercise. So 2 minutes. I just want to pause our call. Magdalene, stay on the call. I'll send, or rather be alert, I'll send an email invite shortly. And then we will continue with cos rule. And then when we're finished with cos rule, we'll do Euclidean geometry. Yeah, and that will be our introduction into Euclidean geometry.
Advice on what to do during the late nights and given your time of meetup. So yeah,
Okay.
because
So-
I know ex-notation mo fita ga ka 8 but what I have to up here supper.
Yeah.
Then from 8 up until 9, that's our supper time. Then
Okay.
from 9 all the way up until whatever time I feel like sleeping at.
You'll be able to study.
And
So
chill.
now you've got a grip on your personal schedule.
Yes.
That's fine. I love that for you and congratulations. At least then for your math and science, you'll get the remedial support, remedial
Yes.
learning support. You also get access to digital tools study support. And in the coming month, we're going to do exam readiness preparation.
Now I remember why my mom was so proud about my physics in term 1. We did an experiment,
in class.
yes. And
And-
since they were mixing chemicals that come from cars, so
Oh.
I was just an Albert Einstein of cars.
Okay. So, anyway, let's carry on with cosine rule, ne? Cosine rule is also examinable. You can get asked to prove it in the exam. The nice thing about cosine rule is that it uses more Pythagoras theorem.
Yeah.
Ne? So sine rule is proved or proven. Was it proved or proven? Hey, English guys. Using
Proven means someone else done it for you. Proved means you've done it and there's actual work for it.
okay.
That's how they
We'll
differ.
we'll have English class for that in future. Go, Mr. P. Using area of a triangle. And cosine rule, we prove using Pythagoras theorem, Pythagorean theorem. Again, Pythagoras was a Greek philosopher and scholar
Yeah,
who
he was
studied
bored.
geometry in ancient Egypt, right? So he then came up with the famous Pythagorean theorem.
See?
But in any case, we will just split the screen here so that we analyze the proof for an acute angled triangle as well as for an obtuse angled triangle. All right. Right, now the important thing about the cosine rule is that somewhere there it's got a negative. And the negative, we will see how we get it. All right? But let's start with an acute angled triangle. and we will have a perpendicular height. This side will be A, this side will be C. Sorry, that angle will be A, that angle will be angle C, that angle will be angle B, meaning the side AC will equal B, that will equal C, and that will equal A, and that will equal C. Now, between A and C is the point D, which is where the perpendicular height goes from point B to the base AC. And now in triangle BDC, A squared, BDC is this one, eh? So A squared equals BD squared plus DC squared, right? And DC equals AC minus B. Or rather, B minus DC. B minus AD, sorry. B minus AD. So that will be BD squared plus side B. Remember, B is this whole side here. So that means DC is B minus AD. Yes, B minus AD, all squared, right? Now we can use maths from algebra. And what is this? First, outer, inner, last. Yes, distribute the whole expression. So we will have BD squared plus B squared minus 2BAD plus AD squared, right? But we also know that BD squared plus AD squared equals C squared. Also from Pythagoras, right? And that is in this triangle here where BD squared and AD squared equal BA squared or C squared, right? And we can also do the same, or rather we can say that A squared, which is BC squared, equals wait. A squared B squared. Oh. Okay, it's fine. So in this equation here, we've got BD squared plus B squared minus 2B times AD plus AD squared, right? So now you notice we've got a BD squared there and an AD squared there. So that means if we look at this triangle with BD squared and AD squared, we can substitute C squared in the place of BD squared and AD squared, so that A squared equals C squared plus B squared minus 2 times B times AD. So again, to clear the confusion, BD squared and AD squared, which are a direct result of this calculation, mean that because we are looking at Yes, c squared, which is in this triangle ADB. Triangle ADB, right? So from triangle ADB, c squared equals that squared plus that squared. Right, AD squared plus BD squared. And C squared, if we take from there, we can substitute those two, and then we reduce our equation like that, right? So this is looking at both triangle BDC and triangle ABD. Right, so now, again in triangle ADB, the cosine of angle A equals adjacent AD, which is, AD, divide by hypotenuse, which is AB, and AD, okay, we'll just leave it at AD for now. So it's AD divided by C. Now, what we can do is write AD in terms of C, so that AD equals C times the cosine of angle A. And now we substitute this equation into that equation, so that will give us A squared equals C squared plus B squared minus 2 times B times C times the cos of angle alpha. So that's where we get the negative, because we ended up substituting that AD, and we also get the negative from that square there. From that square there, when we perform algebra on it, and then after we substitute those two in the place of C, and then we finally work with the cosine of one of the angles, and then we substitute that into there, and then we get that answer there. And we can also show that B squared equals A squared plus C squared minus 2AC cos B, and also that C squared equals A squared plus B squared minus 2AB cos C. And here's the cool thing about the cos rule. If you're looking for side A, then the two sides which you must have the measurement for and the angle that is opposite the side that you're looking for is always how you think about the expression. So when you think about using cosine rule, think about if you have A and B and the angle C, then you should be looking for side C. If you have B and C and angle A, then you should be looking for side A. And if you have C and A and angle B, then you should be looking for side B. Now what? So in the interest of time, or Tiamo, we might not do geometry today.
I can see.
Yeah, but we'll do geometry on Friday, because Magdalene will have written, and then you're writing maths when? Next week?
Next week, apparently.
Week after next.
Yes.
Okay, so we should have enough time then for geometry practice. Yeah. So then obtuse angled triangle, it's a similar proof, but we'll go with it. Né? So I just want to make sure that the proofs are taken care of, so that we don't have to go back here, and then at least we are done with measuring, with calculating rather, or working with trig, especially these rules here. Right. So when we have an obtuse angled triangle, that will be side A, that will be side B, and that will be side C. Now in BDC, that will be side B. In triangle BDC, which is the big triangle, BDC, a squared, which is the hypotenuse, will equal a BD squared, which is the height, plus DC squared, yeah? And DC is the sum of, so DC or CD is the sum of B and AD. So we'll have BD squared plus B and AD combined, right? And we square that. So now that means we'll have BD squared plus B squared plus 2 times B times AD plus AD squared. That equals A squared. And then again, in triangle BAD, triangle bad, in triangle BAD, if we take Pythagoras again, then we will have C squared, and that equals BD squared, which is the height, plus AD squared. So again, in the place of B squared and BD squared and AD squared, we can write C squared. So that means A squared equals C squared plus B squared plus 2B times AD. Now, the negative comes because in the second quadrant, when we are reducing, if that's theta there, and we are reducing cos of 180 degrees minus theta, we get negative cos of theta, right? So if we take cos of 180 degrees minus alpha, or rather A, for this triangle, in triangle BAD, it will be, cos will be AD divided by hypotenuse, which is C, and that means AD equals negative C cos of angle A. Now if we substitute AD into that, then A squared equals B squared plus C squared minus, because we are substituting the negative in there, then that negative also changes, 2B C cos A. And that's the proof. So now that we have the proof of all 3 rules that Magdalene needs to know for her test on Thursday, we can now apply. So I believe we applied sine rule before. Yes. So now we can apply cos rule in here. Right, so the first problem was, okay. So now we're going to do application. All right, now first application, we have another triangle, PQR. It's not a right angle triangle. It might look like it could be, but it's not. Let's assume it's not, because we'll have to prove. Up there we have P for Mr. P. Down here we've got R and we've got Q. Side Q is 462 millimeters long. Side P is 378 millimeters long. Angle R is 87 degrees. And that's just about all we have. Remember, with cos rule, we have to have two sides making a sandwich of an angle to give us the side that we don't know, right? So, to solve triangle PQR, we will have to find side R, and we can find side R by using cos rule. So it would be the square root of p squared plus q squared minus 2pq cos of angle R. Yeah? We substitute, so we will have 378 squared plus 462 squared minus 2 into 378 into 462 times the cos of angle R is 87 degrees. Right. So, I believe, Tiamo, on your calculator, you can just punch everything as it is.
Something's wrong.
What's wrong?
I'm trying to remember. I did something wrong. I'm sure about it. Whoa.
Is it in class? Let's try and concentrate so that...
Bro, I left the gas on.
In the house?
Yes, I hope my mom could hear it.
She probably smelled it.
Hey, I'm just hoping on that.
She probably smelled it, but...
Let me get back to class. I'll see it when I get home.
Yeah. That's probably the first thing she's gonna say when you get back.
Ish.
Because mothers tend to have that hunch. But anyway, calculator.
I'm like thinking, okay. I took a bath as soon as I got back home. And then my mom told me to do something, but I didn't do it.
So, cos of 87 times 462 times 378 times 2 minus, plus 462 squared plus 378 squared equals. Yeah. So yeah, PQ squared or R squared. Let me not write R squared because I've already gone straight to R. Right? So R squared is 338,000 and 338,048.515891111.
How? Well, mine says 581.
You got PQ directly.
Shoot, we give you PQ.
Yeah, so then I take the square root of that and I get 581.419 millimeters. 419 millimeters. Yeah. And then that just gives us, so 581.42 millimeters. That just gives us the side. But now, to find the other angles, P and Q, we can use sine rule, right? So here, we've used cosine rule. And now we're going to use sine rule for angle P and angle Q. So we will say sine of angle P over P equals sine of angle R over R, and P will equal arcsine of P sine of angle R over R. That is arcsine of P equals 378. Sine of R, that would be the sine of 87 divided by 581.42, and that equals, let's see, so I'll invert that, multiplied by sine of 87 multiplied by 378.
Are we taking it to one decimal place? 2, 3, 4, 5, 6.
And I get 40.4. Let's take it to 2 decimal places. So I get
40.48. That's what I
4
got.
degrees. You got the same?
Yeah.
Magdalene, how much did you get? Did you get, what answer did you get for the angle at P?
Look at my eyes. Tell me do you see me?
Hey, Magdalene, you got the same answer. All right. Then for angle Q, similarly, sine of angle Q over Q equals sine of angle R over R. Then Q will equal arcsine of Q sine of angle R over R. That is arcsine of Q is 462, angle R is 87 degrees, and side R is 581.419, and Q should be, or rather angle Q. So I'll get 581.419 invert times
52,016. Alright, 52,61.
You get 52.
Yeah, 52.61.
Okay, I'll get there. And then times 462 equals, and then I get, 52.52 degrees.
52.
Okay.
52.52. How?
Magdalene, how much did you get? You got the same answer. My internet is unstable this time. You got same answer, ne?
Yeah, 10 minutes.
Or village? Okay. Take your time.
Okay. We'll see who's wager.
Take your
is
time.
right.
Take your time. Take your time.
Magdalene shall be our tiebreaker. You have your own opinion.
Eh?
You receive?
You got the same answer.
What's your answer? Magdalene, I got a question. What's your answer?
Huh?
What's your answer?
This one.
52,61.
Told you.
Okay. Fair enough. That's because we've been rounding off a lot through the calculation. That's understandable. The thing is, depending on how much you round off in the calculation, you will get those differences. But the more you round in each of these steps, ne?
Mm-hmm.
If you round off in this step, let's say you substitute, ne?
Mm-hmm.
So let's say you calculate this, or you calculate this part and then you round it off. When you add it there, already you've rounded off there, so the answer is going to be way different from the closest approximation. So it will be not surprising that we will be in the same region here, but we would differ maybe by the decimals or even the first number before the decimal. Now if we do the same or use that rounded off number, we substitute it there, and still let us substitute, we round off, we will get answers that are almost different. Now what I do is I prefer to work with this as a whole. So you need a bit of practice and experience to do that. But if you are starting out, and with your guys' calculator, the number 2006, your guys' calculator, you can just punch in this thing as it is, and you'll get the answer like this. So I would advise you do that, because then it gives you the closest approximation that you could get. Yeah, one. Otherwise, if you have to do it with the calculator I'm used to, you will fail. You will not pass. Yeah, one. So there are a number of problems look at the solver, but I just want to do one problem, 2 dimensions, 2 dimensions, right? And I think this is where in grade 11 the educators like to trick you and ask you these questions a lot, So we'll just do a 2D problem, 2 dimension, Now I'll just start with this definition here, 1 dimension, and I think there's a video there, 2 dimension and 3 dimension, So the world that we occupy is 3-dimensional. That is because when we think about it,
Mr. P, we made a mistake, me and Magdalene.
Where?
Yours is actually right.
Of course mine is right. But where did you make the mistake?
It's not sine 89.
It's sine 87. Oh, okay. It's fine. If that's the case, then we see where the challenge is. But let's just look at 1 dimension versus 2 dimension versus 3 dimension. In terms of length, area, and volume. If you imagine yourself to be so small that you are a particle and you are there, that space you occupy doesn't have a dimension. But now, if someone extends you a pen, and with that pen, they draw for you a line, and that line goes from where your point is, and it ends there. It's a line segment. Not a line segment. That's the correct definition. What this means is you'll be able to move from this point to that point where the line segment ends and back. But your motion would be very limited. It would be in 1 dimension. That is why in physics you have 1-dimensional motion. So movement on the x direction for moving cars. You remember that?
I remember
that.
Yeah.
And then in grade 12, it becomes 1-dimensional movement in the vertical direction, where you throw a ball or a ball bounces, right? So that's movement in this for vertical and movement in that direction for horizontal. Now, imagine again, you're still that small, but the person who drew that line for you decides, okay, you're too small, but I want you to have bigger space. Now they square that line and it becomes an area. So now instead of moving in 1 dimension, you find that you're able to move in 2 dimensions along the x and y dimension. So what does that mean? It means you'll be able to move in that direction in that direction, but you'll be able to travel anywhere in this space, right? As that dot. You'll be able to travel anywhere in that space. Now that's two-dimensional movement, right? And that's the two-dimensional problems we're going to look at. Now in 3 dimensions, the same person who gave you an existence in 2 dimension is like, no man, I want this person to be able to jump, jump from the floor that they've been moving on. And they decide, okay, there's the floor there, right? There's that floor. But now I'm going to give them a vertical height. And they can now, maybe they're in a swimming pool or they've built a plane and they can fly. What that means is, if that is X and that is Y, that is Z. What that means is you'll be able to move in the X direction and in the Y direction, or between the two at an angle, and you'll also be able to move in the Z direction, which is above where you are. So think about the room that you're occupying now. Where your feet are, that's two-dimensional space. It's flat on the ground. But now when you look toward the wall, that wall goes from the ground to the roof. Now it moves from the two-dimensional space, which is the floor, and it creates walls which enclose the 3-dimensional space. That one. And now in trig problems where you do these 3-dimensional problems, you know what will happen? You'll find they give you a triangle and an angle there. And they'll give you another triangle and an angle there. That's what happens. And they'll give you another triangle on the floor and maybe an angle there and an angle there. And these 3 triangles, they're not on the same plane. This first triangle is on this plane of this wall. The other triangle is on that plane of the other wall. Maybe there's a window there. This one has a door. And this triangle is on the floor.
I see.
So that's the difference between 2D problems and 3D problems. Now the nice thing about this is that y'all are both in grade 11 and 12, but I'm using a grade 12 learning guide for the benefit of our class, meaning that we are able to do both at both grades. It's just that in grade 11 you'll be marked more because the complexity is higher for that grade. But in grade 12 you get less marks.
Yeah, that one I noticed.
You get less marks, but that's because you learn other things, and that's where your other marks come from.
Not to say that grade 12 has much to offer, because most of the things that they speak about, they're from past grades.
Yes.
One new problem.
And that's where the marks come from in the rest of the problem. So now, in this 2-dimensional problem, you can do the next slide. We've got a trapezium. A trapezium is a quadrilateral, a 4-sided figure where 2 of the sides would be parallel, definitely. But in this trapezium, the 2 sides that are parallel, one of the sides is equal to the side adjacent it. Ne? So PS equals PQ, and we are given angle R at 63 degrees. SR is 10 centimeters long, and QR is 7 centimeters long. Right?
Why did I think so many things at once?
What are you thinking?
Euclidean. Well, as soon as you said angle R is I was like, oh, okay, R plus P equals 180.
So this is a nice problem for us to finish off class, because when we finish off this class here, we'll maybe do a 3-dimensional problem, but we will then continue with geometry on Friday so that we accommodate the needs for a geometry class, because geometry is also a topic we need to discuss this week. But anyway, now that we have this, I want you to remember back in grade 9 when you learned this thing.
C, it's a C.
It's a C or an N, but I prefer to write it like this so that at least it introduces a little bit of fun, although maths is not fun for a lot of people, really.
It's interesting.
I mean, that depends on your tolerance for interesting, you know? Right. So, from our grade 9 geometry, we've got corresponding angles.
Co-interior
We've got co-interior angles, very good.
And last but not least, alternating angles.
We've got alternate angles, yes. Alright, so I want us to identify these in here, in our thing. Before we even start answering, let's just try, before we even start applying cos or sine rule, let's just think about this for a second in the context of this, because this is the Euclidean part of a trig problem.
Nah, so Euclidean.
Yes, you are very correct.
I was like, okay, why do I see a Z first of all? I know that where that comes from.
Because remember, when we were proving cos rule, we used in using Pythagoras, we also used algebra where we square a binomial in a bracket, and then we get a 3-term expression.
Look what square root to the square.
Yes, you see. So it just goes to show that these concepts, they can go into each other at different points. Just how Euclidean geometry is geometry, just as analytical geometry is geometry. The one uses logic to prove things, and the other uses quantities and numerical values to determine or analyze situations. So in this case, we can also say that this angle plus this angle should give us 180 degrees.
Sum up to 180.
So 180, that would be 117 degrees here. But we don't know what the angle, we'll call it Q1. We don't know what angle Q1 is. But we know Q1 and Q2.
Is 63.
Okay. Have we proven that with some logic?
Wait, did I say Q1 is 63? Oh yes, yeah, Q1 is 63.
How did you find that out?
Co-interior angles. If you see it the way I see it.
Okay.
Like, wait, let me see if I'm right. 63 plus.
Let's first use logic before we calculate.
Oh.
Let's first use logic. Because what we do know is that whatever this angle is here, it equals that angle there. Because they are alternate angles. And whatever that angle is there, it should equal that angle there. Because this is PQS is an isosceles triangle. Yeah?
I concur.
Yes. So we do know that this angle is 117 degrees. That angle is 63. Angle R is 63 degrees. But yeah, I think it's shy. But in any case, we will be able to revert back to this geometrical reasoning before we get to the final answer. But for now, let's stick to trig, because Euclidean is proving to be limited in some ways. But let's stick to trig, because at least with trig...
This one, Q2, for it to be 117, I doubt.
No, not Q2. the whole angle. That's why the green line extends from there to there. So Q2 will only be this part here. Q2 will only be this part there. You get it?
I'm trying to see something.
Yes. So maybe geometry will not succeed, but let's use we can use cos rule on triangle QRS. So in using QRS, we can say side QS squared must equal QR squared plus SR squared minus 2QR SR cos of angle R. And then that is 7 squared plus 10 squared minus 2 times 7 times 10 cos of 63 degrees. And that gives us what? That's 49 plus 100, 149. So we'll do 63 cos times 2 times 70 is 140 times 140 negative equals plus 49 plus 100 is 149. So QS squared is 85 point. Whoa.
Possible. Remember, all
Then
angles in
I
the
square
triangle
that.
must sum up to 180. So
Yes, that is true. So I get here 9.243 centimeters. That is SQ. And that's like 2 marks. Magdalene, do you follow, ne? You are following us. Alright, and you also get a 9.24.
yes, she sent a thumbs up. She did.
Alright, well done. Now we're going to look at
we're going to have a problem if this entire angle is 117.
no, not really. Not really. We've got the side QS, which is the base of the isosceles triangle PQS. Ne?
Isn't PQ equal to SR?
No, PQ is not equal to SR.
Reason.
They are parallel.
Mm-hmm.
And they're also not given as equal.
I see.
Yes. But if we can find the angle at P, then we could find one of the sides PQ or PS. Alright? And to find angle P, what would we need to find? We would need to solve first triangle PQS. Or rather, we'd need to find one of these alternate angles. Yeah? We'd need to find one of these alternate angles. Okay, let's go back to our fun diagram. So angle Q1 plus angle Q2, ne? Plus angle R should equal 180 degrees. Okay. But maybe
angle
the
Q1 plus some of a triangle must.
no, that's co-interior angles.
I'm still shocked of why Q1 and Q2, because that's the entire angle.
Yes, Q1 and Q2 is this angle.
Hey,
But maybe that's not gonna solve the problem quick. But maybe if we have triangle QRS, we've got a side there, we've got a side there, and we've got a side there. We've got one angle. If we have this angle and that side, and we have this angle, maybe we have this side, maybe we can find that angle Q2 using sine rule. So using sine rule on triangle QRS, then the sine of angle Q2 divided by SR will equal the sine of angle R over side QS, which implies, or rather which tells us that Q2 will equal SR, no, arc sine of SR times the sine of angle R divided by side QS. And when we substitute, we have the arc sine of SR is 10, sine of 63 is something, and then QS is 9.243 centimeters. And now we can get the angle Q2. And when we have it, we will use then Q1 is 117 minus Q2. So we'll just substitute everything after. So let's quickly find angle Q2. Angle Q2 will be 9.243 invert times 63 sine times 10, and then find the arc sine of that. So that would be 74.575 degrees, right? So that means Q2 will equal, so negative
Yeah,
that,
question.
yeah.
Why do you use trial mathematics
What do you mean trial mathematics?
on your calculator?
Like I'm working it in reverse?
Yes.
I'll tell you why. Because this calculator does not use direct algebraic notation. Your calculator uses direct algebraic notation, meaning as you calculate a sum as you see it on paper, when you're writing it down, your calculator can work it out like that directly.
Yeah.
These are old school models, so you have to start working with some maybe not chain rule, because that's like first year calculus, but like it's like you work from inside the problem. You start with that which is going to be difficult to get, so you start there and then you work in reverse.
I saw.
Yeah. So Q1 will equal 42.425 degrees.
Let's put him to the test.
425 degrees, meaning that that angle is also 42.425 degrees, as is that angle 42.425 degrees. Because we used fun to identify all the angles that could be equal, and we could identify that
We
these
didn't
two...
identify P. Why is Mr. P all alone?
Oh, Mr. P, we're going to easily calculate. Because the goal was to calculate SQ, which we found, and then PS, which we can now find because we have worked out the angles at the base of the triangle. So meaning this times 2 equals 84. Now we must subtract that from 180 degrees to get
360.
whoa 42.425 times 2 and then plus 180. So angle at P for Mr. P is 95.15 degrees, right? So now we've calculated that. Then
Let's test if they're correct.
Then using sine rule, okay, so, and this equals angle PQS and angle Q1 plus angle PQS equal 84.850.
Conclusion on Q2.
Q2. Q2 is 74 degrees, 74.5 degrees. 74.5 degrees. And then we end up getting angle Q1 as 42.425 degrees, and that equals angle PSQ, or the angle S1. You can call that S1, this S2. And then that gives us angle P equals 95.15. And because sum of angles in a triangle, now we can use sine rule. So we've got P, or rather the sine of angle P over P equals the sine of angle Q1 over PS. And or rather PS over sine Q1 equals P over sine of angle P, and PS would be sine of angle Q1 times P over the sine of angle P. And when we substitute, Q1 is 42.4, and sine of 42.4 times P is 9.24, and we've got sine of 95.15. Right, so the sine of that, and then we invert it, we multiply it by Q1 is 42.425 sine, and we multiply that by 9.243. That gives us side PS is 6.261 centimeters, which also equals PQ, so 6.261 centimeters. So now we've got all the sides and all the angles in the triangle. right? And the next thing we must do is find the area of the quadrilateral. So we can do this two ways. We can work out cos rule for the first triangle and cos rule for the second triangle, or area rule for the first, or rather, not cos rule, area rule for both triangles, and then we'll get the answer. So,
It shall be for another day.
I just want to capture all of that on video so that we don't, then, yeah, so area rule in triangle PQS, or rather, let's say area of triangle PQS will equal a half times, let's say, QS times, it's half times the one side times the other side. Let's say PQ times the sine of Q1. So it'd be a half times QS is 9.243, PQ is 6.261, and then we have the sine of angle 42.425 degrees. And then also for area of triangle QRS, that is half times QR times SR, times the sine of R. And then we're just gonna add the areas after. So I'm just writing down these formulas and substituting so that it's easier and quicker to navigate. QR is 7, SR is 10, and the sine of R, 63 degrees. All right, so now we do the math. So 42.425 sine times 6.261 times 9.243 times a half. So we get 19.52 square centimeters. How much did you get?
I think I got more.
Yeah?
I got more than that.
How much more did you get?
12,027.
Aibo! Such a big number.
Ish.
Aibo! Ay. We have a problem here. We've got a problem.
Ooh.
And then we do 63, the sine of that, times 10, times 7, times 0.5, we get 31.185.
Yeah, that one we agree on.
Then we can just add 19.52, and the total area
is
50.71 square centimeters. Magdalene, I don't know if you were able to capture all of that, but do you follow? All right, so these notes, they're going straight to classroom after our call, and this video I'll edit it tomorrow morning, and then it should be uploaded by tomorrow. So between tomorrow, when you're at school, and after school, and the whole of Wednesday, you'll have access to a whole 2 hours of this class, so you'll be able to revise as if we're going through the same class. The whole discussion from the proof of area rule to the proof of sine rule to the proof of cosine rule to the applications of all three. Are there any questions in the last 6 minutes that we've got?
No.
No questions. Tiamo?
I live to fight another day.
You live to fight another day. I understand. Just don't fight Uchiha. Because he will send those red eyes your way and you will see things, you'll see flames where they aren't in. I don't have any questions, I don't have any comments, I don't have any suggestions. We can end here. So Magdalene, that covers you for Thursday, yes? Is this everything that you had to prepare for test on Thursday? Eh?
No.
What else did you have to cover?
Statistics only.
Statistics. So you'll be writing this and statistics.
Yes.
Okay, but are you able to do some self-study on statistics?
Yeah, statistics are good, okay.
Okay, that is great. But we're still going to do a lesson on statistics so that we can brush up on concepts that we might be skipping. Ne? All right. You sound very tired. Siamo's tired. I'm also tired.
It's been a long day.
It's been a long day, yeah. So we'll call it a night. Thank you for showing up, and I'll see you tomorrow for science class, ne?
Okay, no problem. Bye.
Bye.